Hello, everyone, and welcome to today's SANS webcast. SEC554, Blockchain and Smart Contract Security. How to lose $280 million with a single line of code. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speaker is Stephen Walbroehl, CISO and co-founder of Halborn Inc. and SANS instructor and course author. If during the webcast you have any questions for our presenter, please enter them into the questions window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to turn the webcast over to Stephen.
All right, thank you very much, Carol. So welcome everybody. I'm glad you could make the webcast, and for those in the future that will be watching this from the recording. So this is going to be a very interesting one on blockchain and smart contract security, and I wanted to go over and demonstrate a very large vulnerability that occurred a couple of years ago on the blockchain, and dive into the technical details of how it happened and what it's dealing with. But before I do that, let me introduce myself and my background. So my name is Stephen Walbroehl. I have actually been going to lots of SANS classes throughout the years. I've been to 560, 660, 760, and eventually it just became inevitable to join in and contribute and make a course around this first. I am the Chief Security Officer and co-founder of Halborn. Halborn is a firm that's focused on blockchain and smart contract security. We do offensive pen testing, security audits. So we see all sorts of different types of deployments and different types of blockchains and different types of vulnerabilities too. So I'm very excited to go into some of this and how it's prevented. And have a couple hobbies around. I'm a comic book collector, and I played guitar in a band for several years before I did all of this. And I'm a guitar player, as you can probably see behind me, lots of the guitars on the wall. So what are we going to go into on this webcast? So this is the agenda and the topics that we have right now. First, going to briefly go into what exactly a smart contract is for those that don't really know, have heard of it and maybe not know what it is, and how it relates to the blockchain. And after we get a little primer on that, we'll go in and I'm going to talk about Parity multi-sig wallet. This is a particular smart contract that was developed and deployed that caused huge impacts to the users of it, where about $280 million of investment was lost forever. And we'll go into the technical details of how that happened. And then I'm going to do a live exploitation on the same vulnerabilities on a local blockchain that I'll stand up and show. And that's going to be a little bit of what a preview is for how the SANS course SEC554 and what to expect from that, and the type of tools you'll use and the type of activities and labs that you'll get into. And then we'll do a close off with a QA. So what is a smart contract? This is the long definition, and we're going to break it down. But it's basically an arrangement between two or more parties exchanging digital assets, where at least one of these parties allocates digital assets at the contract's initiation, which are then distributed to all individual parties in accordance with a predefined protocol. It's a lot of words, so let's break it down. Digital assets, what they mean is Ether or Bitcoin or something different. For the vulnerability we have, this is Ethereum, which is the second biggest of all the blockchains out right now, and it's used for smart contract deployment. When we say digital assets contracts initiation, this is deploying the contract to the Ethereum mainnet or putting it on the blockchain for the public to use and interact with. A predefined protocol, this is the functions that are coded inside of the smart contract. So think of it as a self-contained application, if you will, that is put on the blockchain, and there are functions within there that you can call, whether it's deposit or withdraw, and some other ones that are very interesting and sometimes vulnerable, which we'll get into shortly. And the logic and the state. So predefined protocol in logic and state. So logic and state is very typical to programming. This is all of the transaction instructions that are in the functions, and then the variables like the amount of ether that's stored within it. So How does that relate to a blockchain? Well, so smart contracts and all the functionality actually, they enable the blockchain to move from just a single purpose like Bitcoin, where it's just sending money to somebody back and forth, peer-to-peer exchange. What they do is they enable the platform to use different type of applications. So everything from a supply chain management to a decentralized finance. There's lots of use cases that are coming out day by day. And when you put this on a blockchain, it provides full transparency to the users of it. They can see who's transacting with who. It's not private. It also has a lot of benefits where you don't need a middleman anymore to facilitate transactions. So, just like Bitcoin, where there is no payment intermediary. It's just peer-to-peer based on cryptography. It records everything on the public ledger so that everybody can see. So it's always on the blockchain. You can always go back and trace it on history of who did what, who called what transactions, and we're going to look at some of the ones that from the past in this vulnerability. And no central authority. So this is the term decentralized that is always used. It is decentralized, which means there's no single controlling entity for it, which is a great benefit for security. It moves the security usually from a central entity to yourself. So you're kind of responsible for your own security. All right, so enough about that. Let's talk about smart contracts in particular and how it relates to the code that's inside there. So for a smart contract, the code is the law. So when you have a contract, what is programmed in that contract and sent to the mainnet, that is the law. That is telling you this is how it should function. Do you accept these terms and conditions, apparently? So once it's deployed there, the terms and conditions are set. It's a binding agreement for the way it should function, and the developers release it to the world for you to use. But sometimes it doesn't function how they intend it. Sometimes there's things that are, oh, we forgot to fix that, and can't really patch something on the blockchain. There are newer methods of doing it, such as proxy contracts now or upgradable contracts, but they're still there, and you cannot just go in there and patch it. So when you put a vulnerability on there, it's usually there forever, and we could still go back and look at what happened. So we're going to go into this particular contract, do a deep dive into the Parity Wallet bug. So what is it? In 2017, there was a development team called Parity, and they created a smart contract, and the functionality for that was a multi-signature wallet. So most people know what a wallet is, or a cryptocurrency wallet, where you have your keys. A multi-sig wallet is a wallet where two or more parties have to provide a key in order to unlock it. It could be just one party if you want to, but it allows multiple people. Here at Halborn, we use multi-sig wallets too between some of the employees here if we need to transfer funds. It's a way to add extra layer of security for it, so it takes away risk from one individual. So they had the contract that provided this. It was actually a library contract, and we'll see that soon. And it functions different when you think of multi-sig. It's not like multi-factor authentication where it's something you need, something or something you have. This is actually the two signatures there. So two different parties rather than one party with two signatures. So what happened exactly? So timeline of events. They developed this wallet contract, and they deployed it to the mainnet, and it contained actually two vulnerabilities that were later discovered. One of them was that the contract, it was a library contract, and it was not initialized, which is intended, but it was publicly exposed, which means somebody could initialize it to take control of it. And also, not only that, but there was another vulnerability inside of it where once you had control of it, you could destroy the contract. So they deployed this out. It's a library contract, which is, think of it as like a dependency on another application. All the multi-signature wallets that people would put their money into, they relied on this contract to get the functions that it needed to do in order to conduct this. So they put that out. So it was out there for about 4 months. The users created the smart contracts. They deposited at the time worth $280 million in Ether, and I think Ether was around $200 at the time. Now it's about 400, so this would probably be $500 million today. So they were using it. They put this much in. Then, after about 109 days, somebody posted this on Twitter, and it was on GitHub too, saying, it looks like some anonymous user called the Init Wallet function that was left unprotected and uninitialized for all this time and assigned an owner to that library. So they could convert that library, essentially turn it into a wallet, because now there was an owner for it, and it was their wallet that they could use. So they took control of the contract. That's the address. And then that same user, they opened up a GitHub issue on the Parity wallet contract that people were using, saying, hey, anyone can kill your contract. And we can actually go in, see, I'll go browse to this right now. It's still out here. Here is the GitHub for Open Ethereum. Of course, it's closed from November 16th, but highly celebrated comment here. I accidentally killed it. LOL. Okay. Wow. Oh, you accidentally lost $280 million. No big deal. Well, so they ended up doing this, and a short period of time, that destruct function was called, and all of the users now that relied on that library contract were locked out from ever being able to withdraw the money that they had. One of those users was actually the Parity founder, and the company his name is Gavin Woods, one of the developers for Ethereum. So he lost $90 million from that. So what happened exactly? What are the vulnerabilities that enabled this to happen? So the first one that I briefly mentioned was the Init Wallet function. So the wallet was not initialized, but it was still publicly exposed. So anybody that called this line here, this Init Wallet address owners, they could just send in their address, their cryptocurrency public address, and be the owner of it. And this is actually the transaction where it happened. So we can look at this live, still out there on the Etherscan blockchain. I have this up. So Etherscan is pretty much the public ledger of where you can see all the transactions happening. You could even go in and look at the code. But this was the transaction that was called right here, Init Wallet address. And then this was the address that was provided. And I'm going to show a live demonstration of how this is done on a blockchain so we can see exactly what's involved with it. So it was put in there. They took control of this wallet. And then shortly following that, the other vulnerability was the kill or self-destruct function, where after you take control of the library, you can call this self-destruct function that disables all of it. It's a very dangerous method. There are some use cases to have this in there if it's needed to burn some tokens to take away value from something. But when you leave this externally exposed, then anybody can destroy it. That's not a good thing. One line of code destroys it all. Hence the name of this webcast. So it's pretty dangerous, and I don't know how this made it through, but this is what happens in new technologies, new vulnerabilities. This is the actual self-destruct function that was called, and this is also on Etherscan to see. So somebody called down there at the bottom, the input data function kill address 2, it was in there. They actually killed it without having the address take the funds from it. So wasn't really stolen too much. It was more just locking everybody out where they couldn't use their own funds. So pretty serious impact here. So what I'm going to do now, let's do some hacking so you guys can kind of see this, the technical people out there. What are the tools you use? How do you hack? How do you even interact with a contract in this way to test it or to exploit it? So the steps I'm going to do is I'm going to set up a local private Ethereum blockchain. This is used for testing. It's called Ganache, where we can spin up a blockchain with addresses and deploy contracts to it. Then we're going to compile and deploy a smart contract with all of these functions in there with a tool called Truffle. that we're going to fund the contract. We're going to put some money into it, just like the users had done, and then use a couple commands through this Web3 JavaScript and the Truffle Console to start sending these function calls to it, providing the addresses of where to steal it and get the self-destruct. All right, so I'm going to get out of the demo really quick here and start getting the tools up. So the first one here is Ganache. Just minimize all this stuff here. Okay, so this is the local private blockchain. I'm going to set up a new workspace, and we'll just call this project SEC554 Webcast. And I'm going to add a project in here. And what I'm adding is some initialization features in this Truffle config, and we'll look at this in a second. Okay, and then I'm going to change this port. My local port I have running for the blockchain will be 8545. Everything else looks good. So let's let's make 3 accounts. We're going to have 3 accounts for this test deployment. We're going to have one that's just going to be the account that creates the contract. So you spend a little bit of Ether, and then this would be Parity deploying the contract out. Another account is going to be the unknowing victim that is going to send some money into the contract. And then the third account is going to be an attacking account. And the attacking account is the one that's going to first take control of the contract and then initiate the self-destruct function. So we'll put 1,000 in there and 3. And that should be all we need to get it up and running. Yep, so I'll save this workspace. Okay, so this here is the main interface for a local running blockchain. We can see that we have these 3 addresses created at random. Each one of them has a set of private keys. They have their own transactions and they have their own balance. The transactions will come up on here, and the contracts will come up in here too once we deploy it. So I'll leave this up running. It's running on port 8545. So now what I'm going to do is send these contracts to it. So first, let's take a look at it. Here's most contracts are coded in a programming language called Solidity. There's a couple other ones, Viper, but Solidity is by far the largest one. So this is what the code of a smart contract looks like, and this is one that I created that's a little bit smaller and less complicated than the wallet, but it has the main vulnerability features that we looked at. So you can see there's some functions here. This is a destroy function that we can call. It kills the contract and sends everything to 2, which is the address that you provided. And then this is that first vulnerability for changing the owner to whoever you like. So this function should be protected, but it's marked as public and allows an owner. So you can send it an address like yourself and take control of it. So let's deploy this contract out to the blockchain. And we're going to do this with a truffle command. Do a truffle compile. Okay, so Truffle took these SOL files and compiled them and sent it to our local running blockchain. So this is a Truffle config. This is the configuration that tells it what to do and where to send it. So you can see it's on my local host running on port 8545 and a version of the compiler which matches the contract itself. So now if we look on here, we can see that we have the bad wallet contract is now there. So we sent it, now we have to deploy it. So we compiled it, now it's deployed. So this is as easy as truffle migrate. Okay. So now we've migrated the bad wallet contract here. We have a transaction number. It provided us with an address. This is on the 3rd block, and this is all about the balance that the gas used for all the transactions. So let's go take a look back on Ganache here. So now here's all the transactions that were done, and if we look in the contract, we can now see. Yep, here it is. So here's the details of the contract. This is now we've initialized it. We sent it out to the blockchain to be interacted with, containing the vulnerabilities. So you can see here, owner. The owner is all zeros, which means uninitialized, fine if it's just a library contract. And then this is the address for the contract here. So this is it deployed out there in an initiated state. So now let's let's work on interacting with it. So let's send some money to the contract. So we're gonna go through back to here. Here's the 3 accounts that we created. This first one here was the deployer. So let's use the second one. This will be the victim that's sending money to it. So I'll take this contract address and I'm going to use this send money, quick JavaScript here. So this is using Web3.js. It's a language that you can use written in JavaScript and Node to send commands right here from the Web3. Let me just update this with the correct addresses that were created because it's different every time. So we have a contract address and actually that was the from account here, right? From account, and then the contract address is that wallet. Yep, and that's our contract address. Okay, and I set the amount here as 554. So we're going to send 554 Ether to the wallet. So right now they have 1,000 Ether. So we should see this be reduced by that amount, and then it'll be contained and locked up in the contract. So let's run this one. Run my send money. Okay. And now we can see here the balance is now 446, and the contract contains that balance. Okay. So now it's holding some money inside of it, some Ether, and the owner's still initialized. Okay. So this would be that timeline events, that second one where people are putting money into something. So now let's do the first vulnerability and initialize it as an owner, take control of it. So for this, I'm going to use something instead of having the JavaScript, we'll use Truffle Console. So Truffle Console allows you to utilize and send some commands much easier to do basic interactions with the functions that are on there. So first, I'm going to set up my bad wallet contract that's deployed here, and going to do then W. So this is just basically setting some variables for me to use easily on the next commands here. All right, so we're going to interact with the bad wallet contract that's deployed. Okay, it's actually here. I think I have to change this to wallet real quick for it. Missing an equal sign. Okay, so here is all the details we could see. Yep, now we have our environment is set up with this correct bad wallet contract that we just deployed. Okay, so the environment variable set. So now we're going back looking at all of the functions. We're going to do this change owner function. So we're going to change the owner from the uninitialized to the attacking contract. So to call that, we're just going to do a wallet environment set up and change owner, and we're going to change the owner to here's our address account. So our hacking address is already kind of rich. He has 1,000 Ether right now. We're going to make him richer. So take this address, and he is going to just copy that again. Okay. Let's see if this works. All right. So set the transaction, wallet change owner, transaction hash. We could probably see this much easier on the actual blockchain here. If we look, it's the contract call. Okay, this is the transaction hash that matches to the wallet from that address. Okay, now if we look at the contract, here we go. So now we can see the owner is not 000 anymore. It's been initialized as this address. So that attacking address now is the owner. They just took control of it because that initialize function was not protected and it was publicly exposed. So he has control of it with all the people's 554 ether that's inside of it. That's already bad enough right now. So let's make it a little bit worse. And what we're going to do is now send that destroy function, kill the contract that withdraws the ether to the address of your choice, and then locks everybody else out from it. So go back to here. We'll send our final command to it. The command is this one here. This kills the contracts and sends everything to the address provided, which is 2. So we're going to call destroy. And then destroy runs these, it's called self-destruct now. I guess they have sensitive function names here. So we have the kill function here. So we're just going to use our wallet environment, and we're going to call destroy. Destroy. There you go. And who do we want to send it to? Well, of course, our hacker contract here. So copy this. So now what we should see, if this is correct, it's going to steal the wallet 554 ether that are inside of there, the balance, and then bring it to his attacking address. So now he'll own all of the funds there, and then kill the contract, which will put this owner back to 0 and not be able to be changed ever again. So we have that contract here. We wanted to send destroy, and that's the attacker address. Okay, now let's destroy. All right, there it is. Okay, now let's check, see if it worked. And here we see it. Our attacker is now richer, and our contract has nothing, and the owner back to 0, uninitialized. The contract or library contract is dead, and all the ones that would connect it for this, in the case of Parity, also can't not use it anymore. Just to show that, if we go back and we try the change owner again, say, oh no, let's recover it. I need to get back ownership of this contract. We sent the change owner again. Yep, see, it's dead. So we can't, the address is still 0. So pretty bad. So let's wrap this up now. I have some closing comments about it all. We have some crazy vulnerabilities in smart contract. This is just a couple of them examples. I wanted to, what we look at also, the new class is coming out for blockchain security contract. We go into this particular details, but a whole lot more. Wanted to show kind of like what can you expect from this, what else is out there in the blockchain and security world. So, various attacks, various defense, smart contract exploits like this one and many others. We also look at attacks on privacy and staying anonymous on the blockchain, because they always say, blockchain is anonymous, don't know who you are, but it's not really the case if you have certain behaviors or certain heuristics in the way that you do transactions. And this is a very hands-on, just like all the SANS courses are, and this is why I love all of the SANS classes, is because of the labs. There are tons of labs to do and learn how to do the things like I just did on this demo. You can deploy and interact with the nodes. You can use some of the other tools that are out there for smart contracts, for automated scanning. On the blockchain side, we're going to go into some cryptojacking and malware. We're going to do some solidity exploitation, some enumeration and figuring out some intelligence and reconnaissance on what users are doing and who they are, brute forcing private keys, looking at mnemonics, and a lot more. So if you guys are interested in this kind of stuff, I think that blockchain and smart contracts are getting more important every day. We live in a crazy world now, so sometimes like having your own ownership on things is great technology to provide. And for all the security that's out there, cryptography, it's all built on that. So the mathematics behind it is pretty incredible. So with that, I want to thank you. If you ever want more questions, for those of you that are going to watch this recorded later on, I'm on Twitter, Halborn Steve. You can visit our website, halborn.com. And then for those of you that are live on it right now, I hand it back over to you, Carol, if you want to do some Q&A, I can answer some questions.
All right, thanks, Stephen, for that great presentation. We do have some questions ready for the Q&A.
Sure.
However, if anyone has a question for Stephen, please enter it into the questions window now. Our first one asks, for a complete newcomer to the field of blockchain and smart contract security, do you have any recommendations for learning materials like books, articles, etc.?
Yes. So one of the reasons why I challenged myself to put this course together for SANS is because there's not too much out there right now, and what is out there is very decentralized. I don't know. It's all over the place. You can get a lot of information from looking in the documentations on there, looking at use cases. For myself, I'm studying some of these. There's not like a area to learn it all, but it is coming out. So there's some really good books by Antonopoulos. He's like the Bitcoin guru. There's a couple companies out like Consensus and Open Zeppelin. They're great smart contract Ethereum focused companies. Consensus, they are the ones that have categorized a lot of these vulnerabilities. And Open Zeppelin, they provide a lot of the protection mechanisms that are used to prevent these type of issues. So studying what they're preventing will help you learn this. And I would also say learn a lot about cryptography and private keys, because the technology behind all of this, public-private key, asynchronous, and having the ECC technology. Same thing is built up for the internet right now with SSL certificates. They have a public key. This keeps our traffic private. And that same technology in cryptography is used on the blockchain as well. So study that, and I also say go and look at some of the tools that are being used too, and start utilizing them. Trail of Bits is a company that makes fantastic tools. We use them in this course and learn what they do and when they fit in there. So kind of get the pieces you can, or if not, see if you could find a way to get here. So I consolidate all this into one, and I hope it brings a lot of value to people that are looking for the same answer that you just asked.
All right, thanks. Is it possible for anyone to interact with the Ethereum blockchain using these types of tools, or do you have to go through an exchange? Seems dangerous if anyone can interact.
Yes, so you can absolutely interact with any of these contracts with these tools. There's many tools that you can also use. What I showed you here, these are kind of customizable ones that you can do the scripts to call particular functions and do it. But there's MetaMask. If you've ever used MetaMask before, this is like a Google Chrome plugin for Ethereum. What it's really doing is a GUI front end to send these commands to the blockchain. It's doing these Web3 functions and sending or depositing or trading or doing all of these different contract calls from the GUI. And this is all, yes, it is very dangerous, which is why having code and protected is very important, because this stuff is open source, and open source is really good. I'm a firm believer in open source because I think it helps security when you have tons of people looking at it and auditing it. But sometimes if things go unnoticed, or because of it being in a new industry, a new market, I expect 0 days to happen all the time, or vulnerabilities that haven't even come out. One example, I was talking with Steven Sims, one of my good friends, and he's a SANS instructor as well, about how we can merge together doing a lot of this like ROP chains and exploitation in memory, but on the EVM. So this hasn't even been explored yet. So I'm really excited to maybe do some research for it. Yeah, I would say it is dangerous. And the other question about interacting through an exchange is an easy on-ramp to trade and buy these cryptocurrencies, but there's a term that you'll hear often. It's not your keys, not your coin. an exchange is centralized, it kind of goes against the decentralized nature of blockchain. So they have the keys. They're the ones that can open these wallets, and if they lose it, that's hands off. Or if something happens to them, so an exchange is good if you want to invest and trade. But if you're interacting with contracts, you want to have your own keys and keep it decentralized. And there's a lot of new things like decentralized finance too that's allowing you to do that. We're using like hardware wallets for it. Okay.
All right, thanks. Great webcast. Any timeline of SEC554 class initiative? And several people ask, is the course available already? Or when will it be available?
Yeah, it's very, very soon. Right now we're having testing of the labs right now. So kind of in the QA process, there will be a beta coming within the next, I think, 2 or 3 months. So keep an eye on Twitter, keep an eye on the SANS website. The beta class will be the initiation of this, where we can have live students there, and I believe it's discounted as well, just to kind of like work out any bugs that may be there. But I think it's coming very soon. I would expect, I would say the beta probably January, February, and then full class by the end of next quarter. So yeah, keep an eye on there. It'll be out there soon. But the content is pretty much done now.
All right, thanks. Will there be a certification associated with this course? Will this course other blockchain topics such as permissioned ledger, or will this course primarily focus only on Ethereum?
Great. So those are good questions. No, this course is focused on, this is a 3-day course. The first day is on the fundamentals. So there's a little bit of cryptography in there. We go into what it is, kind of the introduction to blockchain, what makes it up, what nodes are, what transactions look like. And this is mostly for, I would say, Bitcoin and for Ethereum. But we do touch on some other areas that are interesting. We go into stuff around darknet markets and how they're using. We go into what government agencies are using blockchain for now for investigations. We look at Hyperledger. We look at Corda. We look at other EOS, some other smart contract platforms outside of Ethereum. A lot of the exercises are focused on Ethereum blockchain just because there's a lot of tools to leverage right now. But we do go over the content for things other than just Ethereum. And what was the first part of the question? One more time, Carol.
You know what? I'm going to have them resubmit it because I
okay,
did it from my view.
So yeah.
If he didn't answer it, I think. Well, no, you answered the one about when it's available. Let's give them a moment to see if there's something we missed. In the meantime, someone says, "This is so great. I have to take this." Thank you, Steve.
Awesome. Can't wait till you're in there. I remember it was. Is there going to be a certification related to this?
Oh, yes. Okay, great. Thanks, Steve.
I would love to have one. So I already have some cool ideas for it. I need to work with SANS to see the process to get there. But my end objective after this is released is I would love to have the blockchain security certification for this, a capture the flag. Have some great capture the flag ideas, how to go and do competition to steal private keys, and then of course a challenge coin for that too. I hope, because I was obsessed with getting them all, and I did get them all. So having our own one would be awesome too. So yes, I can't say there is a cert yet, but I would love to be working on it, and hopefully there is one coming out.
All right, thanks. That's all the questions we've had submitted. Do you have any closing thoughts you'd like to share?
Yeah, closing thoughts would be, this whole discipline in blockchain and smart contract is something that it's all about the behind the scenes about security. It's about securing your funds. It's about keeping ownership, being self-sovereign, and being able to give power back to an individual, and securing yourself. When you are your own bank is really critical. You're responsible, and with great responsibility comes a great power comes with great responsibility. So you have to make sure that you are equipped with the knowledge to utilize it in the correct way. And this industry is only getting bigger and bigger every day. There's a lot more uses for it. We have some enterprises and corporations now, working at Halborn. I see them. I get to see what's being developed, and I'm really excited about it. So, having this come out now and providing this type of education and knowledge to people is not for me. It's more because it's going to help this whole discipline of blockchain security become more reliable. People will trust it more because right now there's a lot of unknown and uncertainty and even a bad reputation because of the things that happen, like this vulnerability that I demonstrated today. A lot of scams, a lot of like weird stuff, Elon Musk, tweeting from getting hacked to semi-Bitcoin. So that whole negative connotation behind it, it hurts the reputation here. So having this type of education, giving it to the world is going to help all of this just be elevated to, be adopted a lot much better. So it's my closing thoughts for it.
All right. Well, thank you so much, Stephen, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.